Hello boys and girls, happy Tuesday and welcome to science class. So today we are going to be reviewing everything about heat transfer that we talked about so far. So we got conduction, convection, and what's the last one? Radiation, you got it. So we're going to be reviewing those concepts super briefly and then we'll actually take a peek at our next topic, which is fossil fuels. So what you'll need is your science workbook scans, pages 73 and 74. So what I'd like you to do first is to pause this video and read through the questions on these pages so you know what to look for, okay? So go ahead and pause the video and resume it after you read the questions. Okay, great. So we are just going to breeze through this because they're concepts that we already talked about. And as we go through this review of PowerPoint, feel free to pause at any time during the video if you feel like you found an answer to one of the questions in our workbook. I'll also make this PowerPoint available for viewing on Google Classroom. Okay, so let's get started. First of all, what is heat? So heat is just a transfer of thermal energy from one thing to another. For example, the heat from the sun transfers to the metal seat belt inside your parents' car, right? That's heat. And like that example illustrates, heat always moves from a warmer place to a cooler place. And there are three types of heat transfer. The first one is conduction. That's the heat transfer that happens when the little particles bump into each other, but they stay in the same place. They don't move around. So for example, we have a lot of substances that are good at being conductors, meaning that they're good at transferring the heat. And they usually happen in solids, like this pan here, or this pot over here. And what happens in this pot is that, as you can see, it is on top of the stovetop, the hot stovetop, and the heat is being transferred from the stovetop to the pan. And notice how they're directly touching each other. The matters are touching each other, and that's how the heat will start transferring. The particles on the bottom will start to vibrate, and then it will transfer throughout the pan. And some examples of really good conductors, a lot of metals, right? Copper, aluminum, silver. A lot of these are usually used for cooking pans. Insulators, on the other hand, are the opposite of conductors, meaning that insulators do not allow heat to move through them easily. So you usually use them in your houses to keep your house warm and make sure that the heat doesn't escape. So examples of good insulators are plastic, styrofoam, and wood. Yep. The second type of heat transfer that we talked about is convection. And that is what happens when particles actually carry the thermal energy, like think about like a piggyback, right? As they move around. So the difference here is that convection, the particles do move around. They don't stay the same. So we can see this in liquids and gases. For example, if you look at boiling pot of water, which is liquid, you can see that the warmer water will rise up, cooler water goes down, and again, creating what we call a convection current, which is just a fancy way to say that the particles are moving and they spread out. The third type of heat transfer that we talked about is think about the sun, radiation. This is different from convection and conduction in that the matters are not touching each other. They don't touch each other. So for example, you do not, thankfully, need to touch the fire in the campfire to receive the heat. As you can see, the heat radiates and it goes through empty space. You don't need a deliverer in the middle. Examples, the sun, the best example here, toasters. The coils are not actually touching the bread. It's the radiation that is happening. And we got light bulbs. We don't necessarily need to touch the light bulb. If you ever put your hand on top of over a light bulb without touching it, you probably have felt a little bit of warmth. Now let's see all of these three types of heat transfer in action in this campfire. Talked about this example last week, so we got the convection going on over here with the heat warming up the air, making the currents happen. The conduction is it starts at the end of the stick and then it moves all the way throughout. And radiation, which we just talked about. So that was our short review for conduction, convection, and radiation. And now we're going to do a quick preview of our next topic, fossil fuels and fuels. So a fuel, if you just think about the oil in the car, that's fuel. It's basically anything that releases energy when you burn it. So we got examples here. Well, we use fuel for a lot of things. We use it for cooking, heating, drying clothing, making things, subways, cars, transportation, planes. We use fuel all the time. Fossil fuels are basically, they were created back in the Genesis flood. They're basically dead parts, dead remains of plants and animals. They were buried super quickly. The examples, we got coal, natural gas, and gasoline. Now let's talk about unwanted heat. So if you ever ran outside in the summer and became really, really hot and you felt like, oh my goodness, I need AC, or even at school after PE, sometimes you guys will come in and say, Miss Oak, I need AC, right? How do we remove this unwanted heat? Doesn't just happen in human bodies, right? Heated laptops even, or like if the car engine gets heated up. Simple solution, fans. Fans and radiators are used as your laptop probably has a fan inside it as well, and your computers to keep it from overheating. And if you knew this already, sweat is actually super important. God created sweat because it helps us cool down, right? So that is our preview for our next topic and our review for heat transfer. Go ahead and pause the video here and try your best to answer the review questions on pages 73 and 74. All of the information you need is in this PowerPoint. And once you are finished, please resume the video so we can go over the answers. Great. I'm assuming that you already completed these pages. Let's go ahead and go over the answers. Write T if the statement is true. If the statement is false, write a correction for the underlined words. Great. Number 1, true or false? Solids are usually heated by convection. What do you write? It's false. It's not convection, it's conduction. Number 2, metals such as copper, silver, or aluminum are good conductors. True or false? This is true. We got copper, we got silver, and we got aluminum. This is true. Number 3, a fuel is any substance that releases energy when it burns. True or false? This, ladies and gentlemen, is also true. Number 4, the type of heat transfer that occurs in empty space is convection. Convection can occur in empty space. Is this true or false? If you said false, you're correct. What is the type of heat transfer that happens through empty space? Radiation. And number 5, solar radiation is an important source of heat and light for the Earth. Is this true or false? This is definitely true. The sun definitely is important for us. Awesome. Let's go on to the next section. Fill in the blanks. Number 6, the transfer or movement of thermal energy from one substance to another is called, what did you write? Heat. Fantastic. And number 7, heat always flows from a blank substance to a blank substance. So does heat go from a warm to cold substance or cold to warm? Warmer to cooler, very good. 8, substances that allow heat to move through them easily are called, so is this conductors or insulators? Things that allow heat to go through easily. Conductors, great job. Okay, then wood, bricks, glass, and blank, and air are examples of insulators. So there, you could have a lot of different answers for this one. Here are some options you might have put down. Examples of insulators, I'm going to put down plastic. 11. Blank are caused by heated particles rising while cooler particles sink, going down. Those particles get heated and rise while the ones at the top that have cooled off sink. So basically it moves around a lot, right? The process keeps going on. What is that called? Think about the boiling water when you make ramen, right? It's convection currents. Number 12, convection usually occurs in liquids and blank. So the three types of matter are liquids, gases, solids. How does convection happen? If you wrote gases, you are correct. Number 13, blank formed when the remains of plants and animals, so like dead plants and animals, were buried quickly during the Genesis flood, Noah's flood. This is what? Fossil fuels. Fabulous job. Okay, then let's talk about some examples of fossil fuels. Again, you could have a lot of different answers here. Let's look at them over in this slide. So we got coal, natural gas, gasoline. I'm gonna put down coal. Oh, hang on guys, I just realized I made a mistake. Numbers 8 through 9. This is supposed to be over here, right? It does allow. Okay, things that allow heat to move through them easily are called conductors. What about substances that do not allow heat to move through them? So like things that kind of block the heat. Insulators. Yep, I have a feeling that all of you guys probably are watching this video and saying, wait, Miss Oak, you forgot this one. Sorry, my bad. I think I was so excited to talk about convection currents that I skipped number 9. All right, back to 15. When a warmer substance transfers heat to a cooler substance, the cooler substance blanks thermal energy and the warmer substance blanks thermal energy. So for example, like if the sun gives heat to if you think about like the hot chocolate example, and you leave like a metal spoon in there, the hot chocolate will transfer the heat to the spoon, and the spoon will gain thermal energy, meaning it will receive it, and the warmer substance will lose thermal energy. Cool. 74, write the letter of the correct answer. We're going to go through these quickly. 16, heat transfer that occurs when there are no particles to carry the energy is called radiation. 17, heat transfer that occurs when particles of substances bump into or touch each other is called conduction. What about heat transfer that occurs when particles of a substance carry the thermal energy while moving around? That is called what? Convection. 19. Cooking on a stovetop or eating a popsicle usually involves, so think about a melting popsicle. If you wrote A, conduction, you're correct. 20. Boiling water or heating a room often involves convection. If you stand a few feet away from a campfire, hold your hand over a glowing light bulb, or you feel the effect of, well, thank goodness we don't have to touch the fire. Thank you, God, for creating heat transfer radiation. Great. Let's do the last section. What did you write for 22? How is radiation different from convection and conduction? So think about how the sun is different from conduction and convection. I wrote that both conduction and convection need, what do they need to heat? They need matter. They can't just heat through empty space, right? Radiation, however, does not need matter because it can happen without the particles directly touching each other or even moving. So that is what I put. Okay? If you wrote something similar, that's totally fine. It doesn't have to be word for word. 23. What are some ways that fuels are used? Again, there's a lot of different answers here. If you wrote any of these, that's also correct. And lastly, give one way that an unwanted heat can be removed from an object. Couple answers here. You only need to put one. I gave the computer example because I'm so thankful for computer fans. Alright guys, great job. I will see you in a few seconds for reading class. See you soon.